Okay. So, as we said, yesterday we went over a few things. So, quick review. We reviewed the nature of ionic compounds. They're a metal and a non-metal bonded together by the trading of electrons. Okay. We looked at some naming stuff. We looked at the use of Roman numerals to denote the special metals in their name, so we know which one or which charge of that metal is being used. So just a quick review of how that works. Okay, if I gave you this formula here, okay, if I gave you that formula there, we'd start it out, okay, naming it like any other ionic compound. I would write the name of the metal. I'd write the name of the nonmetal, ending in "ide." So nickel sulfide. And then I would go to my periodic table and I would check, does nickel have more than one possible charge? And the answer is yes. Okay, it can be a 2+ or a 3+. So I can't just leave the name as nickel sulfide. I have to tell them, is it the nickel with the 2+ charge or the nickel with the 3+ charge? Okay, I can't just guess, I have to figure it out. So what we always do is we look at the non-metal, because there are no non-metals with more than one possible charge, so they'll never be ambiguous. Okay, so sulfur is in group 16, so it's always a -2. How many sulfurs are in this compound? 3. So how many negative charges do I have in total if every sulfur has a -2 charge? -6. Okay, so on this side, on the non-metal side, we multiply. Okay, so I've got -6. Since all ionic compounds have to have no charge, I also have to have 6 positive charges. Okay, and those 6 positive charges have to come from 2 nickel, right? I've got 2 nickels in here. All right, so 6 divided by 2 is 3. So this is the nickel with the 3+ charge. All right, so to figure out that Roman numeral, okay, this is what you do. You put the charge on the nonmetal and multiply it by how many there are. That gets your total negative charge. Make that a positive number over the metal, divide by the number of metals, and you've got your charge. Okay, so multiply on the right, divide on the left, and you've got your Roman numeral. Okay, and we'll do a few more of those today. Okay, we also talked about polyatomic ions. So if I had that compound, what would I call that? By the way, it'd be a good idea to have your periodic table out right now. What's Li stand for? Lithium. Okay, so we can get that part out of the way. Okay, and what is OH? Hydroxide. Yeah. Okay, so this stuff is just lithium hydroxide. Okay. What if I wrote this instead? So instead of lithium, I've got calcium there, but now I've got brackets around the hydroxide. Does it change what I do? Nope. Doesn't matter how many of anything I have in an ionic compound. I just name the metal and the non-metal, or in this case, the polyatomic ion. That stuff would be calcium hydroxide. Yeah, they're just 2 hydroxides. It would be no different than these 2 things, lithium chloride and calcium chloride. Okay, I don't change the name just because there happens to be 2 chlorines. Okay, it's an ionic compound. That doesn't change the name. Okay, and the same is true if I'm dealing with a polyatomic ion. The only reason for the brackets is I want to say that there are 2 hydroxides. If I write it like this, what am I saying? In this one, there's 1 calcium, 2 oxygens, and 2 hydrogens. In this one, there's 1 calcium, 1 oxygen, and 2 hydrogens. Is that the same thing? No. Okay. Polyatomic ions will sometimes get brackets around them, and that's just like in math. If something in brackets, whatever you've got outside the brackets, you do to the whole bracket. Okay, it's basically just saying there are two hydroxide ions versus there's a calcium, an oxygen, and two hydrogens. Okay, it's just a numbering thing so that you know that everything in that bracket, there's two of it, or three of it if there's a three. All right, we're going to work on that a little bit more today as well. Okay, so we talked about molecular compounds here. Okay, molecular compounds are two non-metals bonded together. Those bonds are very, very strong because the electrons aren't traded there. They're shared. Okay? So the two elements that are involved can't be happy without each other because they need each other to have their outer shells full. Okay? So it's a very strong bond, okay? What we call a covalent bond or a molecular bond, okay, between those two. All right, but it's always going to be two nonmetals. Difference in the naming, we use prefixes in the names for molecular compounds because there's no hard and fast rule for how carbon and sulfur can go together. It could be CS2, it could be C2S2, it could be any number of things. So unlike an ionic compound where they have to balance the charges and there would only be one way they could go together, these could go together in any way, so we use prefixes to tell people how many of everything there are. Okay, and that's all that's different about the molecular ones. Now, on your periodic table, okay, there are a few elements that I'm going to want you to kind of mark. Some, I know, because these were the ones that I used in the final exam last semester, some people already wrote them on there. But, okay, there are also what we call molecular elements. Okay, these are elements that bond to themselves. The most common one that you're probably aware of is this one. You kind of need it to live. Okay, oxygen bonds to itself. It's a molecular element. When oxygen is an element, it doesn't appear as single atoms. It appears as a molecule made of two oxygen atoms. So it's a molecular element. Okay? The other molecular elements are as follows. You're going to want to mark these on your periodic table. Okay? The other molecular elements go like this. Okay? Nitrogen, oxygen, and every nonmetal in group 17. Okay, so they kind of make a 7. Okay, those are all molecular elements that come as a molecule made of two atoms. So N2, O2, F2, Cl2, okay, I2, Br2, okay, they all come as a molecule made of two atoms. Probably a good idea, guys, would be to write it like up here at the top so you don't get it confused with charges or anything like that. Just go like N2, O2, right, F2, Cl2, Br2, right? Just put them maybe at the top. And then another one is hydrogen. Hydrogen is also a molecular element. Doesn't come as single atoms when it's by itself. It always comes as a 2 when it's by itself. Two more, and they're the really molecular elements, okay? And they are phosphorus and sulfur, but they don't come as 2s, okay? Phosphorus comes as a molecule made of 4 phosphorus atoms, and sulfur is an 8. Okay, so when sulfur is by itself, that stuff that smells like rotten eggs, okay, it is actually a molecule made up of 8 sulfur atoms. Okay, it's going to be important when we get onto like reactions and stuff for you to know those. Okay, it's not gonna affect our naming or building compounds or anything like that, but it's just good to know them for later. Okay, does anybody need those anymore? All right. We got like the first 4 done here yesterday, right? If I recall. We didn't get them all finished, though, did we? Okay. So let's pick up where we left off. I think we got to 6, didn't we? Yesterday. Okay. So let's have you try the last 4 there. These are all molecular. All right, so put your prefixes in. Okay. So the first, remember the rules are first non-metal gets named exactly as it appears on the periodic table. Second non-metal ends in I. Put the prefixes in as appropriate. Okay, give you a couple minutes on those and then we'll go through them together. Okay, let's have a look at these ones here. So for number 7, what is Si3? Trisilicon. Okay, and P4?
Tetrasulfide.
Tetraphosphide, right. Okay, so trisilicon, tetraphosphide for number 7. Okay, in number 8, how many sulfur do I have?
1.
Just 1. All right, so we go sulfur. And what prefix is going to go in front of this?
Di.
Dichloride. Okay, and then for number 9, we have silicone again, and we've got 4 hydrogens. So what's the prefix for 4?
Tetra.
Okay, so this is going to be silicone tetrahydride. Okay, now, just the other day I told you, hey, hydrogen's a metal. It's the most metallic thing there is. And now it's a non-metal. How do I know? Because hydrogen can actually do both. How do I know if it's acting as a metal or a non-metal? Yeah, which side it's on. Okay? If it's listed here, it's second. Do we ever list metals second? No. So if it's listed anything other than first, it's a non-metal. If it's listed first, it's a metal. So you'll never get a molecular compound where hydrogen is listed first. Okay, that's how you tell the difference. If hydrogen is acting as a metal, it will be first. If it is not first, it is acting as a non-metal. Okay. All right, number 10, okay, boron, what prefix goes in front of that?
Tetra.
Tetra. Okay, so tetraboron, tricarbide. Let's see that one. Questions on the molecular? Okay. I mean, we didn't add anything to what you learned last year in Science 9. These are exactly the same rules as before. Okay. Here's the challenge. Now, some of these are molecular. Some of these are ionic. Some of them need Roman numerals. Some have polyatomic ions in them. This is where it gets challenging. Now you have to decide, is it ionic or is it molecular? Okay, do I need prefixes? Do I not? Do I need a Roman numeral? Do I not? Okay, that's the challenge. So, I would like you to try these ones. Here's your tips. If it starts with a metal, it's ionic. All right, so if you see a metal listed first, you follow the ionic rules. You look for Roman numerals if it's ionic and it has multiple charges. Okay, that's really everything else. Okay, same rules as before. All right, I'll give you a few minutes to work on those, and then we'll go over like the first 4. I'll give you a few minutes. We'll go over the next 4. Okay, get as far down as you can. So for our first one here, is this ionic or molecular? It's ionic. Lithium is a metal. Okay, so it has to be an ionic compound if there's a metal in it. And then I would write that it is simply lithium chloride. Yeah. I don't need any Roman numerals here or anything like that because lithium's only got one possible charge. Now on the second one, is that ionic or molecular?
Ionic.
It's ionic. Chromium is a metal. So I'll follow the ionic rules and write chromium fluoride. But am I done? No, because chromium's got more than one possible charge, right? It can be a 3 or a 2. So I've got to do the Roman numeral thing here. Fluorine is always a -1. Okay, so 3 times -1 is -3. That means I've got to get 3 positive charges out of the 1 chromium atom that is there. So that means that chromium has to have a charge of 3. So this is chromium, Roman numeral 3, fluoride. That looks like a smile with a missing tooth. Okay, 3. All right, questions on that one? For number 3, ionic or molecular?
Molecular.
It's molecular. Those are both non-metals. Do I need a prefix on the first one?
Nope.
No. So phosphorus. What do I put now? Bromide, right. Number 4, ionic or molecular? It's ionic. Zinc is a metal. All right, so we'll follow the ionic rules. Zinc, iodide. Do I need any Roman numerals?
Nope.
Nope. Zinc is always a +2. It doesn't have more than one charge. Okay, how many people are done 5? Okay, let's have a look at 5 as well. Maybe we'll go up to 6. All right, ionic or molecular?
Molecular.
Molecular. Silicone is a non-metal. All right, so this will be silicone dioxide. You can hyphenate that too if you want. Doesn't really matter how you write it. All right, and number 6, ionic or molecular?
Molecular.
Molecular. Carbon's a non-metal, so this will be carbon. What prefix am I putting on?
Tetra.
Tetrasulfide. Okay, I'll give you a few more minutes on these other ones here. All right, so number 7. What's TC? Technetium, yeah. Okay, and it's a metal, so this is what kind of compound?
Ionic.
It's ionic. Okay, so this is technetium. I spelled that wrong, didn't I? I did not. Okay, technetium and iodide. Okay, this one really pulls people into wanting to put a prefix on there because of the big number. Right? They know it's ionic, they know technetium's a metal, but because it's this giant number, they just feel like they gotta put a prefix on that. Okay, remember, the rule is if it's ionic, it does not get prefixes. All right, first one with a polyatomic ion in it. That stuff is gonna be sodium hydroxide. And by the way, if it has a polyatomic ion in it, it must be what kind of compound? Ionic. If it's got ions in it, it's ionic. Just a little trick to remember. If you're taking anything from the table of polyatomic ions, it's an ionic compound. Okay? So this stuff will be sodium hydroxide. This is the active ingredient in oven cleaner. So if you've ever sprayed that white foamy stuff, okay, on the inside of your oven to clean it off, that is sodium hydroxide. It is an incredibly strong base, which is why it dissolves all the burnt on crud inside your oven. All right, number 9, ionic or molecular? It's ionic, calcium's a metal, and it's got a polyatomic ion in it. All right, so I follow the naming rules. I write the name of the metal, calcium, and I write the name of the nonmetal. In this case, a polyatomic ion. What's SO4? Sulfate, yeah. Okay, just because it's got a polyatomic ion in it doesn't change the rules. Okay, we still name it like an ionic compound. We just write the name of the polyatomic ion instead of a element, a nonmetal. All right, how many people are done up to number 12? Okay, I'll give you guys a few more minutes then to catch up to me here. let's have a look at number 10 here. Is this ionic or molecular?
Ionic.
Ionic. It's got a polyatomic ion, and potassium is a metal. Okay, so this is an ionic compound. All right. So we would write potassium, and then this big long thing, permanganate. Yeah, it's tough to pronounce. Permanganate. Okay. Potassium permanganate actually used to be used as an antifungal. Okay, like during the World War II and the Korean War, soldiers would put it on their feet to keep fungi from growing inside their boots. Okay, it did have one side effect though. It's pretty little purple crystals when you see it in its true form, but as soon as it dissolves in the oils in your skin, it turns brown. Okay, has this strange side effect. So if you have really, really like fair skin, the staining is quite obvious. Okay, if you have darker complexion, then you probably wouldn't even notice it. But I had this kid, geez, now it's like 24 years ago. Okay, he never ever listened to me, ever. And we had this stuff in a lab situation, and my instructions were don't touch it, okay, because it'll stain your fingers, and it's not something you can wash off. Like it has to exfoliate, okay, like your skin has to peel away for the stain to go away. It goes pretty deep. And he comes up to me with the sample tray, and he's doing this. Coder, these are really cool. And I'm like, yeah, Brett, they are. Look at your fingers. All the way past the first knuckle. And this guy was pasty white. Like he was really like borderline albino white. Like and his skin was stained dark brown all the way up past the first knuckle on those 3 fingers. It didn't come off for like 3 weeks. Okay. He still never listened. You thought something like that would make you listen better, okay? But he got teased like relentlessly over the next few weeks about, where his fingers have been. Yeah, it's like really dark brown on really fair skin. It was quite funny. But it didn't make him listen any better. All right, how many people have done number 11? Okay, let's look at 11. Ionic or molecular? It is molecular. They're both non-metals. Okay, nitrogen monoxide. Right, we don't put a mono on the first one, just on the second one. And we usually just write it like this, monoxide, rather than mono-oxide. We just go monoxide. Okay. All right, how many people have done 12? Okay, so ionic or molecular? It's ionic. Beryllium is a metal, and it's got a polyatomic ion. Okay, so this is beryllium. What's CN?
Cyanide.
Cyanide. Yeah, that's really poisonous stuff, actually. Okay, so if that's beryllium cyanide, this would be barium cyanide. Yeah. Okay, number 14, ionic or molecular? It's ionic. Sodium's a metal, and HCO3 is a polyatomic ion. Okay, this stuff is sodium, hydrogen, carbonate. You have almost definitely seen, if not used, this stuff many, many times. What's its common name? You probably have a box of it in your fridge.
Baking soda.
Baking soda, yeah. Sodium hydrogen carbonate is baking soda. Sometimes also called sodium bicarbonate. Okay. All right, last one. Ionic or molecular? It is molecular. Now, how many people saw this and noticed it was on the chart of polyatomic ions as well? Okay, so this happens sometimes. Sometimes you can have a molecular compound, that's what this is, okay, that has the same formula as a polyatomic ion, right? It can happen. Polyatomic ions cannot exist alone. So you'll never see one written like that. It would have to be part of an ionic compound, so there have to be a metal with it. So even though you might see and go, oh, that's supposed to be phosphate, it would only be phosphate if it was attached to something else. If it's by itself, it's not a charged particle, it's a compound. And this stuff would be phosphorus tetraoxide. just a little thing to be aware. It doesn't come up that often, but it does come up once in a while. Okay, so this, if you see something and you think, oh, that might be an ion, if it isn't in a compound with something else, it's not. Okay. All right, questions on that stuff? Is that feeling okay? All right, want to quickly review going the other way. Right? We've been looking at, I give you the formula, you write the name. Now we need to look at, I give you the name, you write the formula, right? Which is probably the one we'll use more often. So what if I gave you this? Sorry, I just, with that, more coffee. More coffee is necessary. What did I just say we were going to do? Go the other way, right? Let's do this. Disulfur. That's what I meant to do. So reading that name, would I be dealing with an ionic compound or a molecular compound? Molecular. It's got prefixes in it. If you see prefixes, you know you're dealing with a molecular compound. Plus, it's two nonmetals. All right. So to write the formula for a molecular compound from its name, is that pretty easy? Yeah. There's no dropping and swapping or anything like that. You just use the prefixes, right? How many sulfurs are in this compound?
2.
How many oxygens?
1.
Done. Okay. Molecular compounds are super easy. Because there's no math or crossing over or anything like that with molecular compounds. You just know the prefixes and you write the appropriate number and you're done. Okay? Ionic compounds are different. What if I gave you this? Let's go with. Okay, so I did spoil that one. I said the ionic compound. So we already know it's ionic. Okay, what's the symbol for magnesium?
Mg.
Mg. Manganese is Mn. Yeah, they're close. Yeah. Mg is magnesium. Okay, and what's the symbol for fluorine? F. All right. So I'd write the two symbols, but these are charged because this is an ionic compound. What's the charge for magnesium? 2. 2 plus. What's the charge on fluorine? -1. It's in group 17. Okay? This is where you do your swap and drop, or drop and swap. It doesn't matter what order you do it in. It'll work out the same either way. Okay? So I like to drop and swap. Okay? So it's 2 drops and swaps to here. 1 drops and swaps to here. We don't write ones when we're writing a chemical formula. I'm done. MgF2. Okay. Is that ringing a bell from last year? Okay. Here's one you haven't done. Ionic or molecular? Ionic. Cobalt's a metal. Okay, so I'd write CO, and I would write nitride, so that's N. What's the charge on nitrogen? -3. Yeah, it's in group 15. What's the charge on cobalt? 2. Okay, the Roman numeral tells me that's the whole point of having the Roman numerals in there. Otherwise, I'd have to guess. Okay, the Roman numeral tells me when you do the formula, use 2 plus for the charge. Okay, that's why it's important to have them there. So now, can I drop and swap? Yep, I'm ready. Okay, so 2 goes over here, 3 goes here, we're done. CO3, N2. Okay, so the Roman numeral part, the harder part is writing the name. Okay, if you're given the Roman numeral, it's just telling you what charge to use for your drop and swap, and that's nothing you haven't done 100 times or more. Okay, what about this one? That's supposed to be in brackets. This one's still ionic?
Yeah.
Okay, so for ionic compounds, we write the formulas. Lead is Pb. What's its charge? 4 plus, yep. And oxide, O, what's its charge?
-2.
Okay. Now, the reason I picked this one is there's something we need to be aware of that happens in this compound. When I drop and swap, the 2 will come here and the 4 will go here. Am I done? Or is there one more step? Maybe you guys didn't run into this in Science 9.
Simplify.
Simplify. Remember, ionic compounds just need to have their charges balanced. That has to be done by the lowest possible number of atoms. Okay, so if you have a compound that's ionic and you can reduce it, you must. Okay, you never reduce a molecular compound. Okay, if you got 2 and 4 in a molecular compound, it's because the prefixes told you that's what it was, that's what it is. In ionic compounds, because it's about balancing charges, we always go with the lowest terms. So that's going to be PbO2. Okay, ionic or molecular? It's ionic, okay, so I would write the formula for my metal, and beryllium always has a charge of +2. And then I would write my nonmetal, which in this case is a polyatomic ion, right? Nitrate, which is NO3, and nitrate has a -1 charge. So at this point, I still do everything the way I would have done if this was beryllium chloride. I'm still going to drop and swap. All right, so the 1 will go here, but we don't write 1s, and the 2 will go here. Am I done? What do I need to put around this?
Brackets.
Where? Outside the 2 or with the 2 outside the brackets?
With the 2 outside the brackets.
2 outside the brackets. Okay, because if I leave it this way, I'm saying there's 1 beryllium, 1 nitrogen, and 32 oxygens. I'm pretty sure that's not the case. Okay, so what I want to say is there are 2 nitrate ions in this compound. Right? That's when you need to use brackets. I mean, you can always use brackets with a polyatomic ion, even if you're not putting a number outside of them, but you don't have to. This is when you have to. You have to separate those numbers and say, this number applies to this whole ion. Okay, everybody all right with that idea? So that's the only time you would use brackets. You just need to say, this is enclosing this whole thing. It's not just applying to the last part of it. Everybody okay with that? All right. I think we'll leave it there for today. You guys have worked pretty hard. We'll work on this a little bit on Tuesday, but we do have to start getting ready for our first lab next week.